Okay, here we go. First question says, we want to find the derivatives of the functions. Alright, so 1a. Let's rewrite the original. Alright, so we know we always bring this down, multiply by the coefficient, and then decrease the power by 1. So this one would end up being 30 x to the 5th, right, 1 less than 6, plus the 3's coming down here, 21x squared. Now remember, over here we have an understood exponent of 1, so that'll be minus 2x to the 0, and anything raised to the 0 is 1, so that's just 1. And then you can't take the derivative of the constant, that just goes away. So this one should be, I'm going to say y, I'm going to say y prime, alright, so equals 30x to the 5th plus 21x squared minus 2. 30x to the 5th plus 21x squared minus 2. Alright, let's look at b for a second. It says 4x to the 3rd plus 5 times 3 raised to the x. So we have an exponential function there. I'm going to get rid of this one here. So what I did was I went back and just double checked how to do derivatives of exponential functions, right? So in terms of if f of x is e to the x, then f prime of x equals e to the x, okay? And if f of x equals a to the x, so that's some number a, f prime of x equals a to the x ln of that constant. So ln. So this should be, let's bring it up here. So the first thing is going to be 3 coming down, 12x squared plus. Now this is just a constant, so it's going along for the ride. So if I come over here and if I say f of x equals 3 to the x, f prime of x has to be 3 to the x ln of 3, right? So the constant just goes along for the ride as 5 times 3 to the x ln of 3. And I'm quite sure, yeah, that's the answer that the teacher has at the end of this exam. Alright? Okay, let's get rid of this for a second. We're going to get into these, sorry, taking a while. We're going to get into these power quotient rules and product rules, right? But first we have one, if we look at 2a, y equals 3t squared. What I'm going to do is rewrite those exponents in the denominator so that they're all like numerator level. So this will be 12, and this is t to the negative 1/2, right? Minus t to the negative 2. Now we can more easily take that derivative. Y prime equals 6t, and this is coming down, right? I should say minus 6t to the negative 3/2, right? I always subtract 1 off of that exponent. This is coming down, we say plus 2t to the negative 3. If I rewrite that so that I don't have negative exponents, I'll have 6 minus 6 over t to the 3/2 plus 2 over t to the 3rd. And that is the answer that the teacher had. So let's look at B. Our quotient rule says the derivative of f over g is f prime g minus f g prime over g squared. So let's do this one. So really, that's f and that's g, right? So first, f prime g, the derivative of e to the x is e to the x. So e to the x times g, x squared plus 1, minus f, e to the x, times the derivative of g, which is just 2x, isn't it? Okay, all over g squared. X squared plus 1 squared. Now I have an e to the x in both terms in that numerator, so I am going to factor it out. And what's left is I'll have x squared. I'll have x squared plus 1 minus the 2x. So I'm just combining those into the standard form of that quadratic. All over x squared plus 1 squared. And that's what your teacher had as the answer. Okay? Let's look at the next slide. Well, it's the same thing on the next slide. I'm just going to do it over here. So I have another quotient rule. F over g derivative is f prime g minus f g prime all over g squared. So let's tie this one. Whoops. Let's go back. All right, f prime is going to be 2z times g minus f z squared plus 1 times the derivative of the bottom, which is just 3, all over 3z squared. That whole thing squared is going to be 9z squared, isn't it? All right, so this turns out to be 6. That's a z. 6z squared minus, I'm going to distribute now, 3z squared plus 3 all over 9z squared. All right, let's combine like terms. This will be 3z squared plus 3 over 9z squared. I'm noticing I have 3 as a common factor. So I will factor it out of the numerator, and it's going to be in my denominator. So 3 goes into 3 once, 3 goes to 9 3 times, so it'll be, whoops, z plus 1 over 3z squared. Your teacher, oops, I lost something. Well, these are z squareds. Uh-oh. Notice something. When I distributed here, this has to be a negative. So let's get that fixed. All right. All right. That's a minus 3. Sorry about that. minus 1. This is still a z squared. So I'll have z squared minus 1 on top and 3z squared on the bottom. So, lesson there, watch signs, right? I probably should have distributed it and left it in parentheses and then distributed that negative 1. Well, lesson learned here, right? Okay, let's look at this one right here, B. And let's make some room. All right. So this is the quotient rule, which means f times g prime, that's f prime g plus f g prime. That's the product rule, right? So take the derivative of the f here, which is 20r to the third minus 2 times g, which is e to the r, plus the original f, 5r to the fourth minus 2r plus 3 times that e to the r, because the derivative of e to the r is e to the r. Now I'm going to factor out the e to the r. E to the r from here, right, and here. So what's left? 20r to the third minus 2 plus 5r to the fourth minus 2r plus 3. So the last step is collecting like terms, isn't it? So e to the r times, and I'm going to write it standard so that the largest exponent's first, so I got that, plus 20r to the third, okay, I got that, minus 2r plus 1. And that's what your teacher has on the on the answer key. Okay? So here are the two answers. I'm going to do a little erasing, and then we're going to do these limits. Okay? So, it's hard to erase sometimes. Hard to erase. So, let's look at these limits. Because when we originally look at this thing, let's look at here. It's the limit as x goes to infinity of x to the 4th plus 3x over x to the 4th plus 2x to the 5th. Truly, we want to pull out the largest exponent that we have there. So we're going to pull out x to the 5th. So that what we have over here is an x to the 5th over an x to the 5th. So if I pull an x to the 5th out of x to the 4th, I have 1 over x there, don't I? And then if I pull it out of here, I have plus 3 over, make sure I'm doing this right. Yeah, 3 over x to the 4th, all over, pull out an x to 5th, so that's 1 over x plus 2. See, those cancel. So now what I have is the limit as x goes to infinity of 1 over x plus 3 over x to the 4th over 1 over x plus 2. Well, anytime you have an x in the denominator and we're taking the limit as x goes to infinity, that thing's going to 0. So my numerator is 0. Now, we need to make sure, though, that our denominator isn't 0. So we'll double check that. Well, this goes to 0, but we still have a 2. So it's 0 over 2, so the limit is 0. And that's what your teacher has. Okay? I want to do the last limit. And what I'm going to do is take us to a clean slide. Oops, I really can't do that. Let's do it on this page and then I'll erase. So it's the limit as x goes to negative 2 of 5x to the 4th plus 5x to the 3rd minus 10x to the 3rd all over x squared plus x minus 2. Alright, well what we ended up doing, we want to get rid of that denominator if we can. So we pull out 5x to the 3rd. We're able to factor that out. And what we have left is x squared plus x minus 2. Guess what? That's the same as my denominator. So those cancel. So now I have the limit as x goes to negative 2 of 5x to the 3rd. Alright, 5, negative 2 to the 3rd. Negative 2 to the 3rd is negative 8. 5 times negative 8 equals negative 40. And that's the answer. Alright, so I got us up through, if I go back for a second, up through 4. I'm going to stop this video and continue on number 5. Okay?